Hello and welcome to JD's Network Training. In this session, we'll be looking at private addresses and subnetting. I do recommend you having strong binary math skills before you start this session, but if you don't, that's fine. Go ahead and check out Khan's Academy. They have really good lessons on this subject matter. First up, we'll be looking at Class A addresses. So a Class A private address just means the first octet is a 10, and the Class A mask is associated with /8. Although you can use a longer mask, it just means that the Class A address has been subnetted, but as long as this first octet's a 10, it's still a private Class A address. There is also Class A addresses on the public internet. If your first octet is 1 through 126, it can be a viable Class A public internet address. And the binary math for a Class A address is associated with the first bit being a 0. And so all the rest of the bits can be whatever we want, but there is an exception to this. If they were all ones, you would have 127, and 127 cannot be on the internet, cannot be used in the LAN. It's only used as for loopback for testing local systems. Class B networks, this can be a little confusing when you first look at it because you'll see two different masks. You just have to realize that a Class B mask associated with a /16, meaning the first two octets. If the first two octets are part of the network, it can be a Class B network mask. We have a /12 here. All that means is the private address range for Class B. The second octet can be 16 through 32. But actual Class B networks we'll see on the actual internet is 128 through 191 in the first octet. And for the binary math to add up right, you'll always have a leading 1, 0, and then the rest of the bits can be whatever you want, depending on what address you're going to use within this range. But you have to remember, the 12 is just stating the private address range we're allowed to use, and the actual Class B mask is 16. Next up, we're going to look at Class C networks. So once again, we have two different masks. Can be a little confusing at first. Know that if you're talking about a Class C mask, it means /24. But if you're looking at the private address range within your LAN that you can legally use is a 192 through 168. These first two octets here, they have to be specifically that 192, 168. No changing here to be a legal Class C address in your LAN. The second two octets, we can do whatever we want with them. And for a Class C address to be on the public internet, you're going to see the first octet being 192 through 223. And if we look at the binary math, they'll have a leading 110 for these first three bits. And then the rest of the bits can be whatever within this range if it's going to be on the public internet. Next up, we're going to be looking at subnetting. Got a few examples here. So how I do this is I differentiate which bits. So in the red, you'll see these are all network bits. These last two bits are host bits. So when I think about this fourth octet here, how many different networks I could have within this octet, how I do the math is I always start with a 2. So if you do 2 and then the amount of bits is the exponent, this is how I do it mentally. 2, 4, 8, 16, 32, 64. I know I can have 64 networks within this fourth octet. Also, you need to be able to calculate how many hosts you can have on this network. I kind of do the same thing. I go 2, 4. Always start your binary 2 math with a 2, not with a 1. And so if I can have 4 hosts, I know that one has to be a network, one has to be broadcast. So I'm actually going to have 2 hosts with this mask because these are all network addresses. And with this next example we're looking at here is that if any of these network bits are changed, it's going to be a different network. And this might be hard to see looking at the addresses. You might see the first 3 octets here are the same, but being how the mask is longer and it cuts into your fourth octet, you can actually change the network with the 4th octet address. So the host 1 and the host 5 are actually on different networks because their network bits have been changed. For our next example, I just want to kind of point out, although this is a Class B network and is a Class C mask, you're allowed to do that. And this is the subnet of a Class B network. We can kind of do whatever we want within our LAN, but it's not allowed, and it doesn't get on the actual public internet anyways, because our ISPs will block private addresses. But that's a whole nother lesson in itself in netting to get on the internet. So what we look at here is that these bits are all the same. So these host bits are changing, they are different, but these two hosts are on the same network. And then if you look at the third network here, because the actual bit in the network range changed, it's on a different network. We have one more example left. And here I just want to point out the special octet. Here the special octet is the 2nd octet. So these first 12 bits represent the network, and these last 20 bits represent the hosts. So you'll see the host bits are exactly the same, but because the network bit changed, these two hosts sit on different networks. Thanks for watching this video, and I hope you were able to learn something.